So I want to show a few more things about the i.onik Wi-Fi-Cloud Hub router thing. The previous video was more lighthearted, less about the security issues and more like a sketch. So I want to use this video to focus a bit more on the security issues. First of all, when you simply unbox this device and start using it, it will create an unprotected Wi-Fi for anybody to connect to. And as you have seen in the last video, anybody can then easily connect to it and get code execution. Generally, we want products to be secure by default because most people don't want to bother or simply don't have the knowledge to secure it themselves. Thus, this is a huge issue. Regular home Wi-Fi routers, at least in Germany, come with a long random Wi-Fi password by default. Obviously, it's a good idea to change it anyway because you trust the manufacturer and so forth, but first of all, you are safe from just a random person abusing your open Wi-Fi for malicious activity. And it's also not a default key shared between all devices. And of course, something like this costs a lot of money during manufacturing because each device has to be personalized. It's just an additional step you don't want if you produce low-end consumer electronics. But let's explore a few more things. Last video we have seen an admin interface that allows executing system commands. So it was absolutely easy mode to get root on this device. But just for showing off some other techniques, let me show another way how you can execute system commands. As you know, there's a web server running on port 80 which can execute programs via CGI. And this web server allows access to browse files on the USB stick. I found it by reviewing the web server configs after I already got root access, but you could figure this out by either unpacking the firmware or checking out the Android application which has the URL where we can find the USB stick content in there. And you probably know already where this is going. We can simply create a shell script that can execute system commands and put it onto a USB stick. We can do this by first specifying what interpreter is used for this file, in this case it's a shell script, and then we read from standard input a string and execute it. And the result will be simply printed to stdout. CGI defines how programs interface with HTTP requests, and the post data, which is basically the body of an HTTP request, is passed to a program as standard input. Thus we can simply send the command we want to execute as post data, and the output of the program will be sent back as an HTTP response. We have that now on the USB stick. Plug the USB stick into the device and then simply access this file from the URL, which will cause it to be executed. Now we just have to simply send a command with the post request and we get the result back. Another basic root shell. If you remember from last video, besides the admin there was also a root user with a password that we didn't know. I tried to use hashcat to brute force the hash in etc password, but I had not much luck. My one graphics card is not that good. So I tweeted and asked if anybody has better luck cracking the hash, and who would have thought, a little bit later, Dissector comes back with the password. His rig was way faster than mine, so thank you very much for helping out. This means we can use this password now to log in via Telnet, and we don't need the exploit from last video to change the root password. And every one of these devices shares this root password, so no need for an exploit, just log in as root with this password. You could call this a backdoor, or being less paranoid, a simple developer debugging credentials left on there carelessly. Either way, it's bad. But let's take one step further and look at the device as if a user would have enabled encrypted Wi-Fi. Because all these attacks require you to have network access to the device. You could argue that these are all trusted services locked behind the secure Wi-Fi. But being only connected to this Wi-Fi is really annoying because you don't have any internet connection. But the device can also act as an access point. The Wi-Fi list with the XSS issue is actually intended to connect to another Wi-Fi. If you do that, there are two ways you can use the device. If the device is connected to another Wi-Fi and you connect to the Wi-Fi of the device, it's basically a router. You can get now access to the internet through it. This means all traffic going through it can be analyzed. So it could be an easy device to open an unencrypted Wi-Fi, let victims use the internet through it, and you can then man in the middle all the traffic. The other way to use it when it's connected to another Wi-Fi is to be in that other Wi-Fi. and now access the device via its assigned IP. And here's the issue. Even if the device's Wi-Fi is protected, it doesn't matter because anybody on the other side of the network can still access it. And it's badly configured because it exposes all these ports and services on that interface as well. This means when you use this device in any untrusted network or have an open Wi-Fi, it can be easily taken over. There's one last thing I want to show. All those web interfaces don't have a CSRF, cross-site request forgery protection. This means we could build a website that when visited will send a request to execute a system command. Basically what we have done with our Python exploit in the last video. To do this, we first start with an HTML file that contains a form. This form will target the URL that is responsible to execute system commands. And we can set the HTTP method to post. And if you remember, the command is sent simply as command. So we add a hidden form element for the post data. I think it would be fun to overwrite the index HTML with a string that we hacked it. Our plan is to use this form to submit a post request to the admin backend when a victim opens a website we control. And to do this, I create another HTML file that will be the actual landing page, and then use an iframe to embed the attack HTML site with the form. And then we can use some CSS to hide the iframe from the victim. Now we can simply add a short script to the attack HTML code, which will automatically submit the first form on the site, so it will trigger the post request. We can use a simple PHP debug local web server to test this. So now we can access this website in the browser via localhost on port 8080. Now the site loads, it loads the hidden iframe. The hidden iframe will then auto-submit the form, but we run into the issue that the admin backend requires a username and password. But that's not a problem. We can simply add those credentials into the URL. Now it should not bother us again. So if we reload the page now, the loaded hidden iframe will submit the form, which will issue a post request with a command that should overwrite the index page of the Wi-Fi hub router. Didn't work. Oops, the main index HTML page is actually in the control subdirectory. So let's fix that. Do it again. And now instead of showing the administration interface, it says the device got hacked. Nice. Changing the admin password to protect against this wouldn't help in this case, because remember, the form to change the admin password is not password protected either. So we can do the technique we just used, cross-site request forgery, to change the admin password first and then issue the code to execute a command. Fancy pantsy. I think in the next video we are going to have a closer look at the hardware.